Hello everyone, so I'm going to try to do this update in one video if I can. I'll try to move as quick as possible here. But this is the Canadian model, this is the newest run. So here we go. Your initial wave that formed the low pressure is out over the water here. This is it right here. And then you have your trough coming in from the west. That's going to be coming through and combining with the initial wave that formed your low pressure off the coast. Alright, so this is what we have right now. Here's this trough. You can see it's starting to become negative. However, in the most recent runs of the models, this trough axis is just not becoming negative quick enough to bring heavy precipitation back into northern New Jersey, northern New Jersey, New York City, and at least central and western Long Island. The trough doesn't become negative quick enough. The low does close off at about the same time that it's been projected to in all the models, but because the negative tilt isn't as great as the models were showing earlier in the weekend and stuff, the heavier precipitation stays off the shore and the low actually closes further to the east. All right, so we will look at the radar in a minute, because there's currently bands of heavy snow over Maryland, Delaware, and the coast of southeastern New Jersey. From what's happening right now is you have your initial wave, which is out here, and then you have this trough coming through, and there's a lot of spin on the eastern side here. And what it's doing is it's creating an area of surface low pressure. So there's technically two areas of low pressure. There's one associated with the trough and one associated with the initial wave. Now, the surface area of low pressure is bringing heavy snow into the west here. Now, I think that interpretation is right. I apologize if it isn't, but I think that's the interpretation I'm getting from this, because otherwise, I can't really explain why an area of low pressure pops up along the coast here, but that's what I think it is. The western trough coming in created a surface low. You have your upper low to the east here with the initial wave, and then as this closes off, these two will come together and you get one big area of low pressure. The energy becomes more consolidated. But because you have two different low centers, let's go to the next run here. Notice again your initial wave is out here, and these two are starting to come together but not quite yet. Notice though, you have two areas of precipitation. You have one back here. This will become the primary focus. It will become the primary low of the storm. And then you have another area of low pressure out in here that's associated with your initial wave. I'm confused. I don't know. I can't tell if this is the upper low or if this is the upper low. I would think that this low formed along the coast, so I would think that's the surface low. But I could be wrong. This might be the upper low and this might be the surface low. But let's just for the moment say that there's two areas of low pressure, because that much we do know. The one associated with the initial wave coming in and the one associated with the trough. Okay? And so you get two areas of precipitation and one that's extending back. This is currently what it looks like. Southeastern New Jersey, Maryland, Delaware, Eastern Virginia. You're getting decent amount of snow right now. I think you could see 2 to 4 inches from this. Maybe even up to 3 to 6 in extreme coastal locations of southeastern Maryland and Delaware there. I think you can pick up a quick 3 to 5, 3 to 6 inches with these heavy snow bands, which we will look at in a minute. But the thing I wanted to show you is in the new model runs, pretty much on all of them, take a close look here. This is your initial wave. You can see that it's like still kind of hanging out here. It's not really that connected to the trough. Now when you look at the new old run, it's a little bit more connected. Old run it's not, new run it is. Right? Oh, I'm sorry. Hold on a second. There. This is where we were. So in the new run it's a little more connected. Old run it's not. And you can see, look at this, 2 areas of low pressure on this one. Here, 1 area of low pressure. 2, 1. So what this is telling me is that this trough is actually combining a little bit later with the initial wave than previously forecast, and what that tells me is that this second area of moderate to heavy precipitation might extend a little bit farther north into central New Jersey, and I was not forecasting that before. But now here's the thing. As soon as this energy consolidates and the one primary low, whether it be the upper low or the surface low, closes off, well, once that energy closes off and it begins to strengthen, you get the circular flow around the low, so it starts to wrap moisture around and spew it back on the western side and the eastern side, so you get almost like it's going to be like a cyclone, like a hurricane when it gets strong enough. But once that happens, you see these two areas of precipitation. Well, this is going to be all the way out here. This first area of precipitation is going to be shifted into the area out here, and your heavy snow just like says goodbye Long Island and New York City. Bam, we're not going to come for you. That's what the models are showing. So watch this now. This is the old run. Sorry, let's go to the new run. So you can see also in the new run, this area of precipitation associated with the surface low, again I'm assuming, the one on the left, is heavier than previously thought. So in the next run here, notice how it's starting to shift east. Two areas of precipitation, one area of precipitation, and then bam, it just shifts east. Alright, and now the Canadian model, I think since the trough combines with the initial wave later, it allows the low to close a little bit later, and so the Canadian model brings in some heavier snow a little bit farther west than previously forecast as well. Like it's coming all the way into central Maine. We did not have that forecasted before, and even into Boston. When I came up with my snowfall forecast, I sided with I did a combination of the Canadian and European models. That's how I did it. Alright, that we're not going to look at all of the model runs. That gives you a basic idea of what we're looking at here. We will take a look at the European, though. That was the Canadian model. So the Canadian model is shifting a little bit farther to the west. The other models shifted a little bit further to the east, only because of, I think the negative tilt is not as prevalent as it was before. However, both the Canadian and the European model bring in additional snow over central Long Island, because remember how I told you? Hold on, let's move in here. Good vorticity. Your initial wave is out here. This is the European, and then this is your trough. And again, this trough isn't as negative as it was in the old run. Again, not by much. If you look at the old run, you really can barely tell the difference, but it's there. Looks the same. To me, it looks more negative in the old run. Clearly, actually. Pay attention to this piece of energy. You see how it's facing this way in the old run? Now look at the new run. You can see it's back in here now. So